Now let us make a goal program of project 5, that is cryptanalysis.rb. In fact, we have again its template in this directory proj5. So let us see this first. Start code editor and then open home icon and double click CS, double click project 5, and then double click this. Okay, this is the current version of cryptanalysis.rb. Okay. Well, I have already prepared the part that we have studied before. So, for example, this is the definition. These are definition of these lines are definition of function deck from here to up to this point to end. Okay. So this is the definition of the function deck. Okay. And then so the actual computation of this program starts from here. We first read in a ciphertext that is stored in the variable ciphertext. Okay. Then here is the part we should consider. This is the part we should consider. That is the computation of the shift number k. Then after finding this number, we use the decryption subroutine to compute the plain text from the ciphertext by using subroutine deck for decoding with the obtained shift number k. Okay. Now let us complete this part. For this, refer the count.rb that we created in the last problem. Okay. So new window and then open count.rb. Okay. This counts the frequency of each letter in the variable ciphertext and shows the index of the most frequent letter. Let us again execute it. For this, activate terminal and go to the room for the project 5. And then ls. Well, we have an English text in this file, message.txt. Let's see it. Cat message.txt. Okay, this is an English text. And then we can count the frequency. P message.txt. So the letter with distance 4, that is the letter E, occurs the most, 13 times. Okay. Recall that this folder contains the challenge ciphertext, which is ex.txt. Let's see it. Cat ex.txt. Okay, this looks like a ciphertext. Let's also count the frequency in this text. Ruby count.rb and then this time from ex.txt. Okay. You see, this time the letter with index, this is 13, okay, occurs 154 times, which is the maximum. Okay. Then it is likely that this letter with distance 13 is the result of applying the shift to the letter E of distance 4. So how many shifts have been made? Now, did you get it? Yes, 4 becomes 13, right? So 13 minus 4, 9. 9 shifts have been applied to E, and then each character of the original text to get this ciphertext. That is, k must be 9. Well, let us tentatively use this number here to define k. Guess that k is equal to 9. Let me use this number here. Okay, this guess number k is equal to 9. Okay, and then execute this program. Save it. Okay, and then Ruby ex.txt. Okay. You see, we could get an English text. Okay, looks like this is English text. So this must be the original plain text. This verifies the correctness of our argument. That is, this guessed shift value, okay, number is correct. So let us embed the computation of count.rb, this computation here, to get this k. Okay, so let's compute k by embedding this number. Okay, so these two statements are not necessary, so we start from here. Okay, copy and paste. Okay. Okay, so let me go through this. Then after reading ciphertext, this part computes the most frequent letter appearing in the ciphertext. And then maybe we don't need this. Okay. So okay. Oh, I'm sorry. There is this part. This part is important. Okay. Copy. So this is only for counting the frequency, and then we should compute the most frequent letter, its index. Okay. Right. So the most frequent letter is computed at this max_dist. And so then, as we discussed, the correct value of shift number k should be max_dist minus 4, the distance of the alphabet E. So E is shifted to this number, right? Okay, now let me check whether this works. Okay, so save it. And then, okay, Ruby cryptanalysis.rb, and then ex.txt. Okay, this time instead of computing, guessing k is equal to 9, we compute the value of k in this way. Okay, let's execute it. Then again, seems like we have obtained the same English text. Okay, and by the way, the program reports that the max_dist is 13 for this ciphertext. Okay, let's try one more example. Well, you remember that we also created ciphertext c.txt, okay, from the message, this message, in the previous exercise. Actually, I forgot this shift number. So why don't we use our cryptanalysis.rb, okay, to get that number? Okay, Ruby cryptanalysis.rb, and then read this ciphertext. Again, we got this English text, which is the message, original message. And then see, the most frequent letter has index 11. Okay, so 11 minus 4, 7 was the shift number for creating this ciphertext. Let's check whether 7 is correct or not by looking at the program enc.rb. Okay, let's look at the program. Encrypto.rb. Okay. All right. Here we set k is equal to 7. Okay. So we are using a 7 for encryption. So this computation of getting 7, was correct. Okay. 11 minus 4 is 7 is correct. So our program cryptanalysis.rb correctly gets this shift number. By the way, it may be the case where max underscore this is smaller than 4. In this case, we would have a negative number for k because k is obtained by max underscore this minus 4. Well, fortunately, even in this case, the program works correctly. Please check it by yourself. Also, let me leave a question why a negative shift number is also okay. Please consider it again by yourself. With this, let me conclude this programming session and all programming sessions. I hope you enjoyed programming.